So we discussed about different concepts in the chapter gravitation, starting from what is force of gravity, what is Newton's law of gravitation, how to apply the formula in different situations, and later we discussed about pressure and buoyant force, and at last we finished the chapter with the Archimedes principle. Now it is the time to apply all this knowledge to solve problems. So see the board there. There is a problem for you. How does force of gravity between two objects change when the distance between them is reduced to half? So to solve this problem, I will tell you two methods to you. Which method you feel easy, you can follow that method. So the first of all, write the force of gravitation formula. F equal to G m1 m2 by r square. Newton's law of gravitation formula or force of gravitation formula. Now here, how does the force of gravity between two objects change? The distance between them is reduced to half. This is important. So masses are not changed, only distance is changed. So therefore, this say this is F1, equation 1. Now the distance r changes to reduce to half, means become r by 2, right? Reduce to half. So therefore, the new force F2 equals to G m1 m2, because the same masses, I maintain the same masses, but the distance now r becomes to half, so r by 2 whole square. Now this is r square by 4, 4 goes to numerator, as you know that 4 into G m1 m2 by r square. This is equation 2. Now I want a new force, so F2 by F1 equals 2. So 4 G m1 m2 by r square whole divided by G m1 m2 by r square F1. So whole these fractions are cancelled. You get 4, implies the new force F2 is 4 times of F1. That means force increased to 4 times. This is the one way of doing, and this is the standard way of calculating and finding the answer. There is one more way, very short. It is used for when you solve the same type of problem in MCQs, multiple choice questions. See here. So this is the first method. Now see the second method. Now as I am saying this, F is directly proportional to m1 m2 by r square. So instead of taking capital G as a constant number, I am taking the proportionality. m1 m2 are not changing, only distance is changed. Change to r changes to r by 2. Therefore, from this relationship, I can write F is proportional to 1 by r square, implies F dash proportional to 1 by, instead of r, you take r by 2 whole square. Here F dash is nothing but new force, which we need to calculate. Now proportional, r square by 4, 4 goes to numerator, so this is 4 by r square. Proportional, 4 into 1 by r square. Now 1 by r square is F. So therefore proportional 4 into F. So therefore, simply you can write F dash equals to 4F. This is also one more method for you, simpler method. Actually, these many steps are not required, as the first time you are seeing this numerical. That's why I am writing the many steps, but within seconds you can calculate. As m1 m2 is constant, leave about that, take this formula F is proportional by r square. See, r is changes to r by 2, so substitute here, you will get 4F. Either you can use this method or that method. Now the next problem for you. Does the earth attract the moon with a force that is greater, smaller, equal to force with which the moon attracts the earth, and why? Let me draw a diagram for you. So this is earth, and around earth the moon is there, the moon rotating around the earth. Now as you know that earth attracts the moon using a force called gravitational force. So this is F1. Because of that, the moon has to fall into the earth. As you know that Moon is not falling into the earth. Why? Because the moon is also attracting the earth with the same force, equal and opposite to it. F2. So F1 equals to F2 and minus. Minus is opposite. When the two forces are equal and opposite, the net force acting on the system means earth and moon system, is 0. That's the reason why earth is not shifting from its place. Moon is also not shifting from its place. So in the same path, the circular path, moon is orbiting around the earth. If any of the two forces, one force has become greater, then there will be lot of changes happen in the nature. As of today, we haven't seen that type of drastic changes in the nature because these two forces equal and opposite. So the answer is same. The second one is why. Why it is same? If you see the formula of gravitational force, F equal G m1 m2 by r square. This is m1, this is m2. So G capital M small m by the radius r square, say r square. So this is the force by the earth on the moon. Now you take F2 force. This is the force by the moon. Same apply. Now you need to write small m capital M by same distance r square. See the two expressions. Two expressions are same. That's why both forces are equal and opposite. The next problem for you. What happens to the force between two objects if the mass of one object is doubled, the distance between two objects is doubled and tripled, masses of two objects are doubled? So in one question, 3 sub questions are there. We'll solve one by one. The first one, masses of one object is doubled. Say the first mass is m1, the second mass is m2, okay, and distance between them is r. Now second mass, the mass of one object is doubled. You can take first mass as second mass. Second mass I'm taking, m2 is doubled, 2m2. Now if you write the formula F equal to G m1 m2 by r square, now the new force F dash equal to G m1, m2 is become m2 m2 because doubled by same distance r square. So if you see this is 2 into G m1 m2 by r square. So this is nothing but equals to 2 into F1. So 2 into F. Why I kept F? Because F equal G m1 m2 by r square. So the first question answer is force is doubled. Now second question. Second sub question. Distance between the object is doubled and tripled. Same masses and distance were taken, but this time the distance is doubled twice. Now what happened to force? See, same F I'm taking here, but F dash new force I am calculating G m1 m2 by the new distance is double 2r. So 2r square. So equals to G m1 m2 by 4r square. G m1 m2 by r square is F. So this is nothing but F by 4. F dash will F by 4. Now the third one, sorry, the second one more thing is that tripled. R becomes 3R. I think no need to do all this calculation. If you want to do by yourself, pause the video and do it yourself, replay, check the answer with me. So F dash equal to G m1 m2 by R changes to 3R, so I can write 3R square. So quickly I am writing G m1 m2 by 9R square it is, and G m1 m2 by R square is 9, so I can write F by 9. 9 times decreased, F by 9. Now third one, masses of two objects are doubled. Let me write here because the first two sections are written there. Come to the third one. Masses of two objects are doubled. So I'm taking m1 m2r here also, but masses of two objects are doubled. So m1 changes to 2m1, m2 changes to 2m2, whereas r remains the same. So if F dash equal to G 2m1 2m2 by r square, so this is nothing but 4 into G m1 m2 by r square. So by this time you should understand what is the answer. G m1 m2 by r square is F, so the answer is 4F. So in this way you can calculate the new forces by using this method.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.